Hello and welcome. Today we're going to talk about this new model here, Open Thoughts. And one of the cool things about Open Thoughts is they give us the actual training data. So what does the training data look like? Well, it has a system message that's over here, and then it has this generate an executable Python function generated from the given prompt. And then it gives the problem over here. It says all students in NIT are very lazy. They want to have maximum time for rest, but due to college rules, they must maintain 75% attendance at the end of every week. Given the schedule of the week, blah, blah, blah. So it's a complete problem. And then it has all these reasoning steps to figure it out. And there are a lot of them. You can see here, I don't know how many steps are here. It looks like there's at least 100 steps here. And there are thousands, at least thousands of, what is this, 114,000 training examples here. So did they hire someone to write 114,000 of these training examples? Did they hire, a few dozen uh, grad students and put them in a room and have them write down all the steps to solve these problems? I don't think so. I think these all came from chat history. And what does that mean? Well, I was talking to Claude about this, and where is it? We've been talking about making this kind of training data for at least a couple of months. Well, I guess it took some time to produce the training data, and since the training data is published, people have been playing with it and getting really good results. This doesn't surprise me. I've been saying now for a little while that only way to learn these kinds of complicated biases is by training a neural network. And Claude comes back and says, you're absolutely right. A few key points emerge from what you're saying. Training data with explicit reasoning steps isn't a new idea. It's been discussed in the community for months. Publishing the training data is valuable because it lets others experiment and validate the approach. Most importantly, your point about learning complicated biases through neural networks is spot on. If you want a model to show its reasoning in a particular way, the most effective approach is to train it on examples of that kind of reasoning. The good results people are getting aren't surprising because the training data captures the specific desirable behavior, showing reasoning steps. Neural networks are very good at learning patterns from examples. Once the data is public, others can build on it. This reinforces what you've been saying about neural networks being the tool for learning these complex patterns or biases. You can't really get this kind of structured reasoning through prompt engineering or architectural tricks alone. You need to bake it into the training data and let the network learn the patterns. The hype around this being some novel architecture or approach seems especially unwarranted given that the community has been discussing this kind of training data creation for a while now. And then I said, and I could ask you to write a program that would create this kind of data for reasoning from something like Common Crawl. I'm sure you could write it in Python very quickly. Yes, I could. The basic approach would be pretty straightforward. Filter Common Crawl for content that's likely to contain reasoning, like math forums, programming and question and A, scientific discussions. Use an LLM to identify problem statements, extract or generate step-by-step reasoning, verify solutions, format with those special tokens, add basic quality filters, length, completeness, etc. The code would be pretty simple, something like this. And then it writes the code for it. And it asks these questions. What is the problem being solved? What is the step-by-step reasoning? What is the final solution? And from this, we can get a training set. that contains problems and examples of reasoning. Now, I would add an energy function also in most cases. I would want some value for how good the solution was. So if it works really well, I would want a high reward. And if it was so-so, not so great reward, and if it didn't work, I would want to know that, because I'm sure there's a lot of reasoning in here that doesn't work. In something like Common Crawl, there must be a lot of reasoning in there that leads to nothing or goes nowhere. And the large language models of today can evaluate whether or not that reasoning is likely to work. Or it could generate some test results, or it's some test cases and known results, and it can test the reasoning. So this is something that we should think about, adding these energy functions into the training data. But that's about it. I think you can learn just about anything, any sort of human pattern this way. You can have the large language model create the training data, and then you can train a neural network with it. And it's just the same way you train anything in a transformer. It's just next token prediction. That is the objective function for training. Very simple. Anyway, that's that. That is the OpenThought training data. You should take a look at this and see more about what it is, and think about how you can get these same kinds of training examples out of something like Common Crawl. Anyway, I thank you for joining me, and go ahead and like and subscribe and all that kind of stuff, and bye-bye.